Okay students, so let's get started with A2 physics के topical past papers for circular motion. Let's get started with it. First of all, state what is meant by centripetal acceleration. तो कभी भी एक मार्क का सवाल आता है in which you are asked about centripetal acceleration. How will you write that? Acceleration that is perpendicular to velocity. Acceleration perpendicular to velocity. Simple as that. Let's move on to part B. An unpowered toy car moves freely along a smooth track that is initially horizontal. Okay. The track contains a vertical circular loop around which the car travels as shown in figure 1.1. Okay. This is the toy car with a mass of 230 grams. Okay. The mass of the car is 230 and the diameter of the loop is 62 centimeter. Okay. Assume that the resistive forces are negligible. This is very important. अगर resistive forces negligible होंगी बेटा तो acceleration क्या होगी? Due to gravity only. Acceleration will be acting downwards. ये negligible air resistance क्यों लिखा है? So that we know कि acceleration due to gravity is acting downwards with a value of 9.81 ms minus 2. State what happens to the magnitude of the centripetal acceleration of the car as it moves from x to y. यार जब आप x से y की तरफ मूव करोगे what will happen to your centripetal acceleration? Simple as that. बहुत सिंपल सवाल पूछा है. First of all tell me what is centripetal acceleration? Centripetal acceleration is velocity का square divided by the radius, right? अब at point x, let's say point x the velocity is vx. Okay, so the centripetal acceleration will be vx square divided by r. Okay, now let's assume the velocity at vy. What do you think, the velocity at vy will be smaller or larger than vx? Let's say in AS kinematics we have studied kinematics equation, right? Let's say I label this as the u, that is the initial velocity, and I label this as the final velocity v. We also have the acceleration due to gravity, that is minus 9.81 ms minus 2. Why did I took minus here? Because it is acting downward. So I have assumed that all vectors that are acting downward have a negative sign and all vectors that are acting upwards have a positive sign. Okay. We have u, we have v, we have acceleration due to gravity. Can I calculate the speed? Yes, I can calculate that. Let's do one thing. Okay, so basically we have v square is equals to u square plus 2as as the formula that we will be using here. Now this might sound confusing at first, but please listen to it carefully. देखो, you are moving in a circle, you are moving from point x, you are moving towards point y. Okay sir, that's correct. Now at point x your velocity is, let's say, u, and at point y your velocity is, let's say, v. Your acceleration due to gravity is minus 9.81. What is your displacement? What is your displacement beta? Displacement क्या होगी from x to y? In the vertical direction, what will be the displacement from x to y? Any ideas? The displacement will be this diameter. What is the diameter? 62. So you have s as well. You have s as well. And since you are going upward, s will be positive 62 centimeters. So can I write everything? Yes. V square is equals to u square plus 2 into negative of minus 9.81 into what is s? 62 centimeter. We will convert it into meter, 0.62. V square is equals to u square minus, let me calculate this answer, 2 into 9.81 into 0.62. This comes out to be 12.16. 12.16. So this is how you calculate your velocity at point y. This v is the velocity at point y. This u is the velocity at point x. कैन यू नोटिस अ थिंग हियर कि वेलोसिटी ऑफ x में से अगर हम कोई चीज सब्ट्रैक्ट करेंगे दैट इज -12.16, फिर आपकी वेलोसिटी एट y आएगी. दिस मीन्स व्हाट बेटा? दिस मीन्स अ वेरी सिंगल स्टेटमेंट लाइन कि वेलोसिटी एट y is less than the velocity at x. And what do we know? Centripetal acceleration का फॉर्मूला क्या होता है? v square divided by r. तो बेटा अगर आपका y पे जो velocity है वो कम है, if the velocity at y is less, what do you think will happen to the centripetal acceleration at y? It will also decrease. Hence, you can say the centripetal acceleration at y is less than the centripetal acceleration at x. Hence, you can say as you move from x to y, your centripetal acceleration decreases. Simple as that. Step by step आपने चीजें लिखनी थी. First of all, you had to write के velocity. You had to basically think in your mind के velocity at y will be less than the velocity at x. If the velocity at y is less than velocity at x, you will use this formula and you will get to know कि velocity अगर कम हो रही है बेटा y पे तो acceleration, centripetal acceleration भी कम होगी. And this will give you the final answer that the centripetal acceleration at y will be less than the centripetal acceleration at x. Hence x से y जब भी जाओगे तो centripetal acceleration decrease करेगी. Simple as that. Now let's move forward. Explain if the car remains in contact with the track why the centripetal acceleration of the car at point y must be greater than 9.81 ms-2. ठीक है, देखो एग्जामिनर हमसे पूछ रहा है कि लेट मी इरेज सम थिंग्स. एग्जामिनर हमसे बेटा ये पूछ रहा है कि वेयर शुड आई पुट दिस वर्किंग. चलो एक काम करते हैं, लेट्स मेक दिस स्मॉलर. ओके एंड पुट इट हियर. Let's make it smaller and put it here. ठीक है, this is the first part की working. Now let's move on to second part. Second part में एग्जामिनर पूछ रहा है बेटा कि यहाँ पे जो centripetal acceleration होगी at y, why must it be greater than 9.81 ms-2? Why should the centripetal acceleration be greater at y? And it should be greater than 9.81 ms-2. Okay, chalo let's see the forces acting on the car. As you can see, the car has these small tires. Okay, the tires and the roads will have friction that will act towards the center. Friction at point x is acting towards the center. What is happening at, what is other forces at x? There is also this weight and there is this centripetal force. So if I want to calculate the centripetal force at x, centripetal force at x plus weight is equals to the friction. Now I can bring the weight to the other side. Centripetal force at x is equals to friction minus weight. Now let's do the same thing with y. On y, if you can see, there is a friction force acting towards the center like this. Friction at y. There will be a centripetal force acting away like this. This is the centripetal force at y. And there will be a weight as well that will be acting towards the center like this. So what will I say? At point y, what will I say? The centripetal force at point y is equals to the weight plus the frictional force towards the center. Now, can you tell me what will happen if a force that is weight is acting on your object? How much acceleration will you have? देखो बेटा, बेसिकली ये कहना ये चाह रहा है कि अगर आपका ऑब्जेक्ट पे सिर्फ वेट लग रहा हो, सिर्फ वेट की डाउनवर्ड फोर्स लग रही हो, तो हाउ मच एक्सेलरेशन विल यू हैव? यू ऑल नो दैट इफ ओनली द वेट इज एक्टिंग, एफ इज इक्वल टू एम ए का फॉर्मूला लगाएंगे, एफ की जगह वेट रखेंगे, डिवाइडेड बाय मास करेंगे, एक्सेलरेशन विल कम आउट टू बी 9.81 ms-2. बट हियर we not only have weight but we also have another quantity, that is the friction. This add ups to the force acting on the car. अब कार पे कुछ इस तरह की फोर्स लग रही है, This is the force that is actually acting on the car, something like this. कार पे बेटा कुछ इस तरह की फोर्स लग रही है, वेट भी इस तरह लग रहा है डाउनवर्ड, दिस इज विल कॉज एन एक्सेलरेशन ऑफ 9.81, और एक फ्रिक्शन की भी फोर्स लग रही है, दैट विल कॉज इट सेपरेट एक्सेलरेशन. तो दोनों की एक्सेलरेशन मिला के क्या हो जाएगी, ग्रेटर देन 9.81 ms-2. सो लेट्स राइट इट हियर. एक्सप्लेन if the car remains in contact with the track, why the centripetal acceleration of the car at point y must be greater than 9.81 ms-2. So we can write it here that the centripetal force at point y is equals to weight plus the friction. Then we can further write weight alone causes a centripetal, weight alone causes an acceleration of 9.81 ms-2. Then we can write that since centripetal force is greater than weight, क्योंकि weight के साथ friction भी add हो रही है, hence the acceleration at point y will be greater than 9.81 ms-2. देखो सिंपल सी बात है, वेट 9.81 ms-2 की एक्सेलरेशन करा रहा है, एंड इफ यू ऐड एन अदर फोर्स टू इट, द रिजल्टेंट फोर्स विल इंक्रीज. द रिजल्टेंट फोर्स इंक्रीजेस, द एक्सेलरेशन इंक्रीजेस, सिंपल एज दैट. द इनिशियल स्पीड of the car which moves along the track is 3.8 ms-1. Determine whether the car is in contact with the track at point y. Okay, show your working. Okay, beta, the initial speed, that is the speed at this point, is 3.8 ms-1. We have to calculate the speed at point y. Basically we have to do part 1 wali working again. So let me erase this. I hope you guys have taken a screenshot of this, of the previous part. 1 second, I will have to erase this as well. Chalo, let's further move ahead. Now we are given the velocity at point x, that is 3.8 ms-1. Okay, we have to calculate the velocity at point y. Our acceleration is what? Minus 9.81 ms-2. The displacement in the vertical direction is what? Let's say something like this. The displacement is 62 centimeter. The displacement is positive because it is acting upwards. The acceleration is negative because it is acting downward. Now v square is equals to u square plus 2as. v square is equals to u क्या है बेटा, 3.8 का स्क्वायर प्लस 2, एक्सेलरेशन क्या है माइनस 9.81, s क्या है 62 सेंटीमीटर, तो इट विल बिकम 0.62. What will be the velocity का आंसर? Let's calculate that. Velocity का आंसर will be 3.8 का स्क्वायर माइनस 2 into 9.81 into 0.62 under root your answer. This comes out to be 1.51. 1.51 ms-1 is your velocity at point y. But we didn't have to calculate the velocity. We had to tell whether the car will remain in contact at point y or not. So for that, the acceleration, centripetal acceleration must be greater than 9.81 ms-2 at point y. Let's calculate the centripetal acceleration. v square divided by r. v क्या है बेटा 1.51 का square. What is r? 0.32. What will this come out to be? Let's calculate it. Divided by 0.32. This comes out to be 7.11. The centripetal acceleration comes out to be 7.11 ms-2. Simple as that. Suggest with a reason without calculation whether your conclusions in part C would be different for a car of mass 480 grams with the same initial speed. Whether this car, if replaced with a 460 grams ki car, will the results be the same? Yes, because centripetal acceleration doesn't depend on mass. Doesn't depend on mass. Simple as that. कोई rocket science नहीं है इसमें. Let's move ahead. I have attached the marking scheme with every PDF, so you can check it as well. Okay. With reference to velocity and acceleration, define uniform circular motion. Now the most important word here is uniform. Whenever you have the word of uniform, this means that पूरे circle में, let's say this is a circle. Whenever you have a word of uniform, this means that पूरे circle में हर पॉइंट पे बेटा वेलोसिटी रिमेन्स कांस्टेंट. इधर भी 10 होगी, इधर भी 10 होगी, इधर भी 10 होगी, इधर भी 10 होगी. So how will we write this? Let's erase this and write down the answer. First of all, we will write that acceleration is perpendicular to velocity. Perpendicular to velocity. Second point will be that velocity is constant throughout motion. Simple as that. Let's move ahead. Two cars are moving around a horizontal circular track. One car follows path X, the other car follows path Y, as shown in figure 1.1. Start and finish are being given to you. Okay. एक कार जो है वो पाथ X पे चल रही है इस तरह, एंड एक ब्लू वाली कार है जो पाथ Y पे चल रही है, समथिंग लाइक दिस. ठीक है. The radius of X is this. The path Y is parallel to and 27 meter outside. Okay. Both cars have a mass of 790 kg. Okay. The maximum lateral sideways friction. दोनों की frictional forces क्या है? Same, meaning both. एक second, 1 second. This force, this blue wali force friction F, and this red wali force friction F would be same. Okay. The maximum speed at which the cars on path X can move around the track without sliding is 94 ms-1. Calculate F. We have to calculate ये वाला F, frictional force F. We are given that the maximum speed here is 94 ms-1. So beta, if the red wali force is friction, what will be the force acting away? What will be this force? It will be the centripetal force. Centripetal force is equals to the frictional force. सेंट्रीपिटल फोर्स किसके इक्वल है? mv स्क्वायर डिवाइडेड बाय r के इक्वल. इट इज इक्वल्स टू द फ्रिक्शन. m क्या है बेटा? कार का 790. v क्या है? v वी हैव टू कैलकुलेट. v स्क्वायर यहाँ पे रख दो. रेडियस क्या है? रेडियस ऑफ द पाथ इज 318 मीटर्स. व्हाट विल बी द फ्रिक्शनल फोर्स? व्हाट विल बी द फ्रिक्शनल फोर्स? लेट्स कैलकुलेट दैट. बल्कि v भी हमें गिवन है. वी आर ऑल्सो गिवन द v. We are also given the V, 94 का square. Let's calculate the frictional force. 790 into 94 का square divided by 318. This comes out to be what? 21951. 21951. If I want to write it till 3 significant figures or 2 significant figures, it will become 22,000 Newton. Both cars move around the track. Each car has the maximum speed at which can handle without sliding. Complete table 1.1 by placing one tick in each arrow to show how the quantities indicated for the car on path Y compare with the quantities indicated on path X. Centripetal acceleration. Chalo. Let's see centripetal acceleration. How does centripetal acceleration of both the cars vary? Chalo. So we know on both the cars the amount of force, the amount of friction force, the amount of centripetal force that is acting on both the cars is same. X पे भी F एक्ट कर रहा है और Y वाले पाथ पे भी फ्रिक्शनल फोर्स या सेंट्रीपिटल फोर्स क्या एक्ट कर रही है? F. Okay. And we also know that the masses are also the same. दोनों का mass भी 790 kg है. So let's write something. Let's write something here. The centripetal force at x is equal to the mass of x multiplied by the centripetal acceleration at x. The centripetal force at y is equals to the mass of y multiplied by the centripetal acceleration of y. Simple as that. Now, can I do one more thing? Yes, I can equate both these values because they are the same. ये f और ये f same है. Let's equate that. Centripetal force of x is equals to the centripetal force of y. Mass of x into the acceleration of x is equals to mass of y into the acceleration of y. This mass and mass gets cut out. Centripetal acceleration of x is equals to the centripetal acceleration of y. This is how you derive the answer for the first part. So the centripetal acceleration of both the parts is same. Maximum speed. What do you think about the maximum speed? Let's see that. If you focus on the formula for centripetal acceleration, let's mark x here, let's mark y here. ठीक है. Centripetal acceleration का formula क्या होता है? v square divided by r. Centripetal acceleration का formula for y भी क्या होगा? v square divided by r. Now can I rearrange these formulas? Yes. Centripetal acceleration into r is equals to v square. Centripetal acceleration into r is equals to v square. Now here I know that the centripetal acceleration for both x and y are same. So instead of is equals to ka sign, I can write something like this. V square is directly proportional to the radius. And I know from the diagram, I know that the radius of y is greater than the radius of x. Radius of y beta is greater than the radius of x. Agar radius greater hai, this means what? Velocity will also be greater. So we will place a tick mark in the greater wali side. Time taken for one lap to elapse. चलो टाइम टेकन के लिए निकालते हैं. वी अगेन नो के सेंट्रीपिटल एक्सेलरेशन इज इक्वल टू व्हाट? आर डब्ल्यू स्क्वायर. सेंट्रीपिटल एक्सेलरेशन इज इक्वल टू आर डब्ल्यू स्क्वायर की जगह क्या रख देंगे? 2 पाई अपॉन टी होल स्क्वायर. सेंट्रीपिटल एक्सेलरेशन इज इक्वल टू आर 4 पाई स्क्वायर डिवाइडेड बाई टी स्क्वायर. टी स्क्वायर दूसरी साइड पे ले आओ. सेंट्रीपिटल एक्सेलरेशन इज कांस्टेंट. ये क्या हो जाएगा? आर यहाँ पे रह जाएगा, यहाँ पे डिवाइडेड बाय 4 पाई स्क्वायर भी कर दो. सो इफ यू क्लोजली लुक एट इट, सेंट्रीपिटल एक्सेलरेशन डिवाइडेड बाय 4 पाई स्क्वायर इज अ कांस्टेंट की वैल्यू. सो टाइम पीरियड इज डायरेक्टली प्रोपोर्शनल टू रेडियस. रेडियस ऑफ y इज ग्रेटर देन द रेडियस ऑफ x. रेडियस ग्रेटर है, hence time period will be greater. You place a tick mark here. This is how this question would have been solved. Let me check the answers. Yes, the answers are correct. Let's move on to the next question. Okay, so now let's start with this question. A large bowl is made from part of a hollow sphere. Okay. A small spherical ball is placed inside the bowl. Okay. And given a horizontal speed. ठीक है. एक यहाँ पे छोटी सी बॉल प्लेस की गई है और इसको एक हॉरिजॉन्टल स्पीड दी गई है. ठीक है. द बॉल फॉलोज अ हॉरिजॉन्टल सर्कुलर पाथ ऑफ कांस्टेंट रेडियस 14 सेंटीमीटर. ओके. द फोर्सेस एक्टिंग ऑन द बॉल आर इट्स वेट जो डाउनवर्ड एक्ट कर रहा है एंड द नॉर्मल रिएक्शन फोर्स आर ऑफ द बाउल ऑन द बॉल. ठीक है. दो फोर्सेज आ गई, एक वेट आ गई, एक रिएक्शन फोर्स आ गई. इफ यू क्लोजली लुक, वन फोर्स इज मिसिंग हियर, दैट इज द सेंट्रीपिटल फोर्स. हम उसे कैसे मार्क करेंगे? ऑलवेज रिमेंबर सेंट्रीपिटल फोर्स ऑलवेज व्हेन यू आर मार्किंग इट ऑन द डायग्राम इट इज मार्क्ड अवे फ्रॉम द सेंटर. ठीक है. सेंट्रीपिटल फोर्स को जब भी डायग्राम पे मार्क कर रहे हो तो बेटा अवे फ्रॉम द सेंटर मार्क करना. जब भी थ्योरी में लिखना होगा यू विल से इट इज टुवर्ड्स द सेंटर. देयर इज अ कॉम्प्लिकेटेड लॉजिक बिहाइंड दैट आई विल नॉट गो इनटू. सिर्फ ये याद रख लो, A2 में अगर सेंट्रीपिटल फोर्स मार्क करनी है तो यू विल मार्क इट अवे फ्रॉम द सेंटर. If you have to provide the direction, it will be towards the center. Okay. Now let's do one thing. This force, centripetal force, in this case is termed as F. Okay. Okay. Now let's divide this reaction force into components. Reaction force will have this vertical component that is R sine theta and will have this horizontal component, that is r cos theta. Now if you closely look at this diagram again, r sin theta, that is the upward force, will balance out the downward force, that is weight. This is equation 1. If you further look at this diagram, r cos theta, that is the force acting towards the right, will balance out the force acting towards the left, that is F. This is your second equation. Now what will you do? You have to prove this thing. W is equal to F tan theta. You will divide equation 1 by 2. Simple as that. W is equals to r sin theta divided by F r cos theta. R and R get cancelled out. And do you study in maths ke sin theta divided by cos theta is equal to what? Tan theta. W upon F is equals to tan theta. W is equals to F tan theta. Here you go. I have proved it completely. W is equals to F tan theta, proven. Okay? Yeah, shown. You can write it this way. State the significance of the force F. What is the significance of the force F? It is the centripetal force. Force F is the centripetal force. Simple as that. Nothing more, nothing less. Let's move forward. The ball moves in a circular path of radius 14 centimeter. Okay. For this radius, the angle is 28 degree. Calculate the speed of the ball. Okay. What will we do? We will apply this simple formula. W is equal to F tan theta. W किसके equal है? M G के equal है. F is equals to what? Centripetal force. mv square divided by r tan theta. This m and m will get cancelled out. R and G will get multiplied divided by tan theta. Under root is your velocity. What is R? 14 centimeter. We will convert it into meter. 0.14. What is G? 9.81. What is theta? 28. Take an under root, you will get your velocity. Let me take out the calculator. The velocity comes out to be 0.14 into 9.81 divided by tan 28 under root your answer. The velocity comes out to be 1.6 ms minus 1. Let's check our answer as well, whether it is correct or not. Yes, we are going good. Let's move on to the next question. Define the term radian. Okay. Whenever you have to define the term radian, you define it like this. The angle. This is a frequently asked question. Examiner usually asks you to define radians every 1 to 2 years. So please remember this definition. The angle subtended at the center of a circle when angular displacement, or you can say when linear displacement, that is linear displacement or slash arc length. What did we represent arc length with? S. Arc length S is equal to radius. Simple as that. जब भी arc length radius के equal होगा, the angle subtended will be known as radian. ठीक है. A stone of weight 3 Newton is fixed using glue to one end P of a rigid rod CP as shown in figure 1.1. Okay. बेटा इस stone का weight क्या है? 3 Newton. Okay. The rod is rotated about end C so that the stone moves in a vertical circle of radius 85 centimeter. Radius भी आ गया. The angular speed W of the rod and a stone is gradually increased from 0 until the glue snaps. Okay. The glue fixing the stone snaps when the tension is 18 Newton. Tension भी आ गई बेटा. For the position of the stone at which the glue snaps, on the dotted circle of figure 1.1, mark the letter S, the position of the stone. देखो हमेशा याद रखो कि whenever the glue snaps or whenever the string snaps, ये हमेशा vertically downward वाले points पे होगा, क्योंकि at this point the tension is maximum. Whenever in the examination the examiner says okay, the glue snaps or the string snaps, this will always happen at a position that is exactly below the center, because at this point the tension is maximum. Okay. Calculate the angular speed of the stone. Chalo. Let's mark the forces here. Let's mark the forces at this point. The forces at this point are one tension and the other one here is only tension is acting upwards. The other two are weight that is acting downward, and the other is centripetal force that is acting downward as well. Let's equate them. Tension is equals to centripetal force plus weight. What is tension equals to? 18 Newton. What is centripetal force? mR W square. What is weight? 3 Newton. Subtract them. 15 Newton is equals to mR W square. Am I given the mass? No, but I am given the weight. Okay, so let's put 15 here. Do I know the mass? No. What will I do? I will divide the weight. Weight given tha mein? Yes, weight given tha, that was 3 Newton. I will divide the weight by 9.81 divided. Do I know the radius? No. I will put instead 85 centimeter. I know the radius. I will put it in meter, 0.85. Do I know W? No. Place a W square here. Now calculate the answer. W comes out to be, let me calculate it, 3 divided by 9.81 multiplied by 0.85, 15 divided by answer under root. This gives you an answer of 7.6, 7.59 or 7.6 radians per second is your answer. Let's check our answer as well. Yes, this is correct. Let's move on to the next question. Define the term radian. I have just done that. This is an FAQ. Please remember the radian key definition. A small mass is attached to a string. Okay. The mass is rotating about a fixed point P at constant speed as shown in figure 1.1. ठीक हो गया. Explain what is meant by angular speed about P of the mass. What is meant by angular speed? Angular speed basically means angular displacement per unit time. Simple as that. A horizontal flat plate is free to rotate about a vertical axis. ठीक है, एक plate है that is free to rotate about its vertical axis through its center as shown in figure 1.2. A small mass m is placed on the plate a distance d from its axis of rotation. Okay, the speed of rotation of the plate is gradually increased from 0 until the mass is seen to slide off the plate. The maximum frictional force between the plate and the mass is given by this. Okay, so the maximum frictional force, where does friction act? I have tell you guys this in the circular motion ka lecture many times. Friction always acts towards the center and it has a value of 0.72 W. Where will be centripetal force? In the diagram, always away from the circle. In theory, you will say it is acting towards the center, but in the diagram, you will mark it away from the center. The distance d is 35 centimeter. Determine the maximum number of revolutions. You basically need to determine RPM, that is N. Okay. Per minute for the mass to remain on the plate. Okay. So frictional force, friction, is basically equal to centripetal force. Simple as that. You have to just do this. Centripetal force. What is the formula for friction? 0.72 W. What is the formula for centripetal force? mR/W square. Can I break this weight down into 0.72 mass into gravitational field distance? Yes, mR/W square. Mass and mass will get cancelled out. Okay. 0.72 G divided by R is equal to W ka square. Let's calculate W first of all. Let's first of all calculate W. Then we will move on to calculate RPM. So ये first of all W calculate कर लेते. 1 second. 0.72 multiplied by 9.81, that is G, divided by what was R? R radius was 35. Okay, 0.35 under root. W comes out to be 4.49. Okay. W is equals to 4.49. Now, do you remember a formula for W? 2 pi n divided by 60, where n is the RPM. 4.49. Do you see that n is the only unknown variable here? 4.49 multiplied by 60 divided by 2 divided by pi. N comes out to be 42.89. If we take a round figure, this comes out to be 43 revolutions per minute. Let's move on to part C. The plate in B is covered when stationary with mud. Okay. Suggest and explain whether mud near the edge of the plate or near the center will first leave the plate as the angular speed of the plate is slowly increased. Okay. Let's say, let me erase this. Let's say there are two mud particles. One is at A, one is at B. Okay. What will be the radiuses for these A and B? The radius for A will be RA and the radius for B will be RB. Okay, 1 second. This has gotten jumbled up. So let me mark it like this. This is RB ka radius. RA ka bhi radius pata hai, RB ka bhi pata hai. From naked eye, you know that RB is looking greater than RA. Just remember this. Okay? At both the points A and B, frictional force will be equal to the centripetal force. Do you agree? Frictional force is 0.72 W. And what is the centripetal force? mRW square. The W for A and B will be same. The masses for A and B will be same. The radiuses are different only. W भी same होगा दोनों के लिए. A for W will also be equal to the angular velocity of W. Now the only differentiating factor here is the radius. The radius of B is greater than the radius of A. This means the centripetal force of B will be greater than A. And if the centripetal force of B, that is this away wali force, becomes greater than the friction wali force before A, it is highly likely that B will fly off first. Dekho, basically what is happening is both A and B are experiencing the same friction ki force, that is 0.72 W. Both of them are experiencing the same friction ki force towards the center. But B has a larger centripetal force. B has a larger centripetal force compared to A. What will happen? B will overcome this friction easily. And will fly off earlier. So you can write it here. Since the radius for the particle that is at the edge of the plate, since the radius of the particle that is at the edge is greater than the radius of the particle near the edge, near the center. Centripetal force of the edge wala particle will be greater than the centripetal force of the particle that is nearer. Hence, edge particle will fly off. Particle near the edge या particle at the edge will fly off. Simple as that. Nothing complicated. Let's move on to the next question. You have the marking scheme here as well. You can check it out. Let's move on to the next question. Define radian. Again, this is an FAQ. I have defined it earlier in the video. You can go check it out. Let's move forward. Why one complete revolution is equivalent to an angular displacement of 2 pi radians. We have to show why one complete revolution is equals to 2 pi radians. Let's do that. We know that, let's say, if we are starting from this point A and we are completing one revolution like this, and again coming to that same point, let's say B. This entire revolution has covered a circumference of what? 2 pi r. Okay. The entire circumference covered during this one revolution is 2 pi r. Have we studied the formula S is equals to r theta? Yes. What is the S here? What is the arc length here? The entire circumference 2 pi r is equals to r theta. R and r gets cancelled out. The theta for one complete revolution is 2 pi. Let's move on to the next part of this question. Okay, so let's further move forward with this question. An elastic cord has an unextended length of 13 centimeter. ठीक है, L naught या unextended length क्या है? 13 centimeter. One end of the cord is attached to a fixed point C. A small mass 5 Newton is hung from the free end of the cord. The cord extends to a length of 14.8 centimeter. ठीक है. L नॉट क्या है बेटा? अनस्ट्रेच्ड लेंथ इज 13 सेंटीमीटर. टोटल लेंथ क्या है? 14.8 सेंटीमीटर. कैन यू कैलकुलेट द एक्सटेंशन हियर? यस, एक्सटेंशन इज 1.8 सेंटीमीटर. ओके हो गया. वेट आपका कितना है? 5 न्यूटन. ओके. द कॉर्ड एंड मास आर नाउ मेड टू रोटेट एट कॉन्स्टेंट एंगुलर स्पीड. ठीक है, इस पॉइंट पे रोटेट नहीं कर रहे. फिगर 1.1 में देयर इज नो सर्कुलर मोशन. ओके. W in the vertical plane about C. When the cord is at a vertical position above C, the length is the unextended length, that is 13 centimeter. ठीक है. जब आपका मास एग्जैक्टली ऊपर है सेंटर के, तो द लेंथ इज 13 सेंटीमीटर एंड अनस्ट्रेच्ड लेंथ इज ऑल्सो 13 सेंटीमीटर. तो इस पॉइंट पे एक्सटेंशन क्या हो जाएगी? 0. ओके. कैलकुलेट, शो दैट द एंगुलर स्पीड of the cord and the mass is 8.7 radians per second. Okay, let's consider this point. इस पॉइंट पे बेटा क्या हो रहा है? आपकी टेंशन अवे फ्रॉम द ऑब्जेक्ट T है. ठीक है, बट टेंशन यहाँ पे क्या हो जाएगी? 0. वाई? बिकॉज एक्सटेंशन इज 0. क्योंकि देख सकते हो टोटल लेंथ दैट इज 13 इज इक्वल टू द अनस्ट्रेच्ड लेंथ. कुछ एक्सटेंशन ही नहीं हो रही, सो टेंशन विल बी 0. योर वेट इज व्हाट? योर वेट इज एक्टिंग डाउनवर्ड लाइक दिस. ठीक है. वेट कितने न्यूटन के इक्वल था? आई हैव जस्ट सेड इट 5 न्यूटन. हाँ, वेट 5 न्यूटन के इक्वल है. और अवे फ्रॉम द ऑब्जेक्ट कौन सी फोर्स एक्ट कर रही होती है? सेंट्रीपिटल. सो वेट इज इक्वल टू सेंट्रीपिटल फोर्स फॉर दिस पॉइंट. 5 न्यूटन इज इक्वल टू mr/w स्क्वायर. ठीक है. मास क्या है? नहीं पता. डू आई नो द वेट? यस, 5 डिवाइडेड बाई 9.81. आर मुझे पता है. यस, 13 सेंटीमीटर, दैट इज 0.13 w का स्क्वायर. 5 and 5 will get cancelled out. 9.81 divided by 0.13 अंडर रूट में डालो इस आंसर को. W comes out to be what? W comes out to be 8.68 radians per second, which is exactly equal to 8.7 radians per second. Simple as that. Let's move on to part 2. The cord and mass rotate so that the cord is vertical below C as shown in figure 1.3. Show that the length L of the cord, assuming it obeys Hooke's law. हमें ये length L निकालनी. बेटा at this point weight का act कर रहा है downward. At this point centripetal force का act कर रही है away. चलो centripetal force को भी यहाँ पे ही mark कर देते हैं. Something like this, centripetal force. और tension कहाँ है? Away from the object. टेंशन इज इक्वल टू सेंट्रीपिटल फोर्स प्लस वेट. अब टेंशन किस तरह निकलती है? टेंशन इज बेसिकली K इनटू द एक्सटेंशन. ओके, दिस इज बेसिकली हुक्स लॉ. सेंट्रीपिटल फोर्स क्या है? mr/w स्क्वायर. वेट क्या है? 5 न्यूटन. अच्छा, अब एक्सटेंशन किस तरह आएगी बेटा? यू आर गिवन द टोटल लेंथ L, अनस्ट्रेच्ड लेंथ क्या है? 13. इन दोनों को माइनस करेंगे तो एक्सटेंशन आ जाएगी L माइनस 13. मास किस तरह निकालोगे? 5 डिवाइडेड बाय 9.81. आर क्या है? लेंथ, दैट इज L. W क्या है? 8.7 अभी निकाला है. 8.7 स्क्वायर प्लस 5. अब अगर देखो यहाँ पे तो देयर आर 2 वेरिएबल्स दैट आर मिसिंग, K एंड L. दिस इक्वेशन कांट बी सॉल्व्ड अभी बिकॉज यू आइदर नीड टू फाइंड K और यू नीड टू फाइंड L टू फर्दर प्रोसीड विद दिस इक्वेशन. लेट्स गो टू द फर्स्ट सिनेरियो. फिगर 1.1 पे आओ. यहाँ पे वेट क्या कर रहा है? डाउनवर्ड एक्ट. टेंशन अपवर्ड एक्ट. बिकॉज दिस इज नॉट इन सर्कुलर मोशन, यहाँ पे सेंट्रीपिटल फोर्स नहीं होगी. वेट इज इक्वल टू टेंशन. वेट क्या है? 5 न्यूटन. टेंशन क्या है? K इंटू ई. यहाँ पे एक्सटेंशन क्या थी 1.8 सेंटीमीटर, 5 डिवाइडेड बाय 1.8. लेट मी सी फाइनल आंसर में सेंटीमीटर में देना है या ओके द फाइनल आंसर इज नॉट गिवन. ठीक है, तो लेट्स अज्यूम कि फाइनल आंसर हमने मीटर्स में ही देना है. तो सेंटीमीटर को हम कन्वर्ट कर लेते हैं डिवाइडेड बाय 100 करके. व्हाट विल द के कम आउट टू बी? 5 divided by 1.8 divided by 100. This comes out to be 277. K किसके इक्वल आ गया? 277. 1 second. 0.7 न्यूटन पर मीटर. ठीक है, ओके हो गया. अब यहां पे क्या करेंगे बेटा? K पुट करो. K की वैल्यू इज व्हाट? 7.7. L माइनस 3. एक्सटेंशन भी मुझे मीटर्स में करनी पड़ेगी. अब L माइनस 3 लिखूंगा और डिवाइडेड बाय 100 करूंगा टू कन्वर्ट इट इनटू मीटर्स. L माइनस 13 डिवाइडेड बाय 100 इज इक्वल्स टू 5 अपॉन 9.81. रेडियस को भी मीटर्स में करना पड़ेगा. L डिवाइडेड बाय 100 एज वेल इंटू 8.7 का स्क्वायर प्लस 5. ठीक है, नाउ लेट्स कैलकुलेट द वैल्यूज. 277.7 डिवाइडेड बाय 100. ठीक है, एंड दिस कम्स आउट टू बी 1 सेकेंड. इसकी थोड़ी सी कैलकुलेशन हमें ज़्यादा करनी है, तो लेट्स डू इट स्टेप बाय स्टेप. 2.777 L माइनस 13 इज इक्वल्स टू 1 सेकेंड 8.7 का स्क्वायर मल्टीप्लाइड बाय 5. ओके, डिवाइडेड बाय 981. This comes out to be 0.385 L plus 5. ठीक है, 2.77 L minus 2.77 into 13. This comes out to be minus 36.1 is equals to 0.385 L plus 5. Okay. अब ज़रा सा रीअरेंज करो इक्वेशन को. ये माइनस 36.1 को आप राइट हैंड साइड पे ले जा सकते हो. दिस बिकम्स व्हाट? 2.777 माइनस 0.385. दिस इक्वल्स टू 2.392 L इज इक्वल्स टू 41.1. 41.1. ठीक है, ये हो गया 41.1. इसको अगर डिवाइड कर देंगे बेटा 2.392 से, L कम्स आउट टू बी 17.2 सेंटीमीटर. सिंपल एज दैट. लेट्स सी आंसर क्या आ रहा है यहाँ पे. यस, 17.2 सेंटीमीटर. परफेक्टली फाइन. दिस इज योर आंसर. सिंपल एज दैट. सिंपल एज दैट, नथिंग कॉम्प्लिकेटेड. ठीक है. Now this is the end of circular motion के topical past papers. I have attached the document in the Google Drive. You can download it and practice it on your own as well.